these violent knee-jerk reactions from the mainstream, and of course they tend to be the things that people look for when they first come to the electric universe. They want to know, what do the experts think? And that poses a bit of a problem, because generally it's not a dialogue between us and the experts, so to speak, but it's more in the nature of bald statements of fact. You know, Newton's laws are sacrosanct, and anyone who questions them is wrong. The same goes for Einstein's theories of relativity. Anyone who questions those, you just don't give them the time of day. But of course, if we're ever going to progress, then science must address questions raised by so-called outsiders, because often insiders are don't have the courage to actually ask these questions, because they know what the automatic response will be. So we come to comets. An electric discharge model of comets was not even on the table at the beginning of the space age, allowing astronomers to embrace Whipple's dirty snowball model as the scientific consensus. But images of comet nuclei show a scarred and cratered rocky surface, and usually you go by the appearances if you haven't had a chance to actually scoop some of it up and examine it in the laboratory. Meanwhile, gravity measurements suggest a comet is a fluff ball, very low density. So what I'm suggesting is there is something seriously wrong with consensus understanding. And I showed this slide on the opening night. It's my opinion that of all the bodies in the heavens, perhaps none will prove more definitive in confirming the electric field of the Sun than the comet, because the cometary display relies on there being a weak electric field centred on the Sun. It is clear that at least by the second half of the 19th century, many scientists believed that comet tails were fundamentally electrical. They looked and they could see the commonality with electric discharge experiments in low pressure gas, and they made the connection. For example, in August 1882, English mechanic and World of Science wrote of comet tails, "There seems to be a rapidly growing feeling amongst physicists that both the self-light of comets and the phenomena of their tails belongs to the order of electrical phenomena." And there are other papers from that era that I could easily add to that. When Comet Halley was flown past, it was a surprise, because the nucleus was found to be blacker than a lump of coal. Some of these small rocks have comas larger than the Sun, and the material that was coming off the comet, instead of just sort of evaporating, it was coming out in jets, which was unexpected. And some of these jets also were on the dark side. Now, if it's supposed to be formed by the heat of the Sun, you do not expect to see jets on the dark side. It had a complex cratered surface. Once again, if you're just ablating material in the heat of the Sun, you would expect it to look more like a melted ice cream than a cratered surface. They exhibit layering. And we've also, having sampled the tail of a comet, found high temperature minerals, just like meteorites. It was discovered by accident that they emit X-rays, and X-rays are a signature of an electrical discharge. Pure and simple.
You can see the aurora in certain wavelengths, even from Earth. Hubble sees the ultraviolet aurora. What's new is that we're up close with Cassini, and that enables us to see details that we've never seen before. Cassini cameras are using visible light, so this is the first time we've got really nice images in visible light. I saw those auroras shimmering and changing with time, sort of flickering, and I just liked the action. I thought it was beautiful. We're always looking for similarities between planets, especially things that we can compare with Earth. In fact, the auroras on Saturn have a lot of similarities to the auroras on Earth. Both on Earth and on Saturn, you have charged particles from outer space crashing into the upper atmosphere and causing it to glow. The magnetic field guides the particles into the high latitudes. So there's northern lights and southern lights, and they're both near the poles on Earth, and that's also true on Saturn. It's near the poles that the magnetic field guides the particles into the atmosphere. I'm a weatherman. I like weather at all altitudes, from hurricanes near the ground to the weather of the top of the atmosphere. The vacuum of space has weather, changing conditions. We're learning about space weather.
Survey Explorer, and its task is to survey the entire sky at infrared wavelengths. These newly released images from the Hubble Space Telescope were taken early last year, and they show aurora dancing around both of Saturn's poles over the course of several days. The aurora at Saturn are created as particles emitted from the Sun are funneled down towards its polar regions by the planet's magnetic field. When this happens, the particles collide with the upper atmosphere, causing the gases there to glow, and it's this faint glow that Hubble has picked up in these new images. Remarkably, the aurora at Saturn's poles aren't exactly the same, and Hubble scientists have put this down to the fact that Saturn's magnetic field is stronger in the northern hemisphere than the southern hemisphere, creating a more intense light show there.
Last month, a cloud of plasma from the Sun hit Earth's magnetic field and sent northern lights spilling across the Canadian border. In the United States, stunned onlookers saw blood-red auroras as far south as Alabama, Georgia, and Texas. For many skywatchers, it was a once-in-a-lifetime event. On the planet called Kourou 2b, it could happen almost every night. Located about 880 light-years from Earth, the gas giant is routinely blasted with X-ray solar flares 100,000 times stronger than anything we experience on Earth. Moreover, the battered planet orbits its star 97% closer than Earth orbits the Sun. When it gets hit by clouds of plasma, or coronal mass ejections, at such close range, the results could be as beautiful as they are terrifying. Kourou 2b probably has auroras visible at all latitudes, even in the planet's deep south, says Scott Wolk of the Smithsonian Astrophysical Observatory at Harvard. Wolk simulates what systems like these could experience, using data from NASA's Chandra X-ray Observatory. The lights would be beautiful to see, he speculates. That is, for the few seconds a human could survive there. Solar flares from the parent star are so powerful, they actually blast away some of the planet's atmosphere. About 5 million tons of matter every second, Wolk says. This could endow Kourou 2b with a long comet-like tail, whipping through the auroral glow. No one knows for sure, however, because the planet is so far away. Despite its tremendous mass loss, the planet is in no immediate danger of evaporating. Kourou 2b is losing about 150 million billion kilograms per year. That sounds like a lot, but it is just a drop in the bucket to a planet more massive than Jupiter. It could sustain such erosion for thousands of billions of years. Kourou 2b gets its strange name from the spacecraft that found it, the French Space Agency's Convection, Rotation, and Planetary Transit Satellite, Kourou for short. A group of astronomers led by Sebastian Schroeder of the University of Hamburg in Germany recently conducted a detailed study of the Kourou system using Chandra and the European Southern Observatory's Very Large Telescope. The results suggest that Kourou 2b has a hand in some of its own troubles. The planet, in part, causes the flares. Wolk explains. Kourou 2b orbits at breakneck speed, making a complete circuit around its parent star in only 1.7 days. Because the planet and star are linked by strong tidal forces, the headlong rush of the planet speeds up the star, causing it to rotate faster than it otherwise would. The spinning of plasma inside a rapidly rotating star creates a more active magnetic dynamo, which in turn gives rise to the magnetic fields that create sunspots and flares. By spinning up the star, Coret 2b sets the stage for flares in general, but it doesn't stop there. By rapidly plowing through the star's magnetic field, Coret 2b probably sets off specific magnetic instabilities that cause flares as the planet passes by. Coret 2b is literally sealing its own fate. Maybe living in a place where auroras are mostly confined to the poles isn't such a bad thing after all. For more information about planets, beautiful and terrifying, visit science.nasa.gov.